and we will go straight back to our chapter 2 presentation. As you know, we started talking about the primitive data types. We said there are certain categories of them: integral, floating point, Boolean data type. We named some of them. We mentioned that Java specification is very concrete regarding the sizes of those primitive data types that represent characters and various kind of integers in memory. We talked about the sizes. We mentioned the floating data type. We saw some examples of that. We also talked about the Boolean data type. And now we're going to continue on with the part that we mentioned already, that each primitive data type comes with built-in set of operations or set of behaviors that comes with it. For example, if you have integer numbers, then of course you can do arithmetic operations with those numbers, and those arithmetic operations are expressed through pluses, minuses, multiplication, division, and things of that nature. But the important thing is that we already started going in this direction. I guess we're still talking about some of the naming convention. We already passed that. So here they are: addition, subtraction, multiplication, division, and of course the assignment. The assignment is when we take the expression, any value in really, and try to assign it to some place. A special case of assignment is that the variable is being declared by specifying the type of the variable, right? And then it is instantly, initialized. So this is sort of like a special case of an assignment. But it is an assignment because the operator used here is the equal sign, is of course the same. So arithmetic operators on floating point types, of course, result in the floating point type. But we also mentioned, jumping right back here, is that the result of multiplication and division on, especially division, this is where people expect it to be maybe a fractional number, but in reality, when there are two integers, like x and y in this particular example, completely meaningless just for the demonstration, the result of this division is the integral division, or the integer division, which essentially disregards the remainder. So we talked about this, just a reminder. So with using floating point types, the expected manipulation of floating points, of course, takes place, and it goes as expected. We mentioned that in any case that you need to mix an integer like this, result 9, and the two, say, doubles, there will be essentially, well, I guess, was it on the previous? No, it's not here. So let's see. Let's start a project today, and we'll say new project, and name this project operations, I guess, or operators, since we're discussing the operators. And I'm going to save it on my projects right here. That will be the location. Just a reminder that I strongly suggest that you don't use any default locations, and always specify which locations you want. I'll just say main app to name my main class, and do create it, so I don't have to create it in a separate step. So the project gets created. Here's my main class. Here's my package name. And I will specify the tagging, and we'll experiment with this, couple of things specified right here. I'll just copy it into my main method and just try to see if well, first of all, recall that result of copy and paste is this kind of incorrect, I guess, indentation. So source format does a beautiful thing. So just there's no excuse to not to use it. So what happens here is that I have an invoice total and invoice count. So those two do look like variables, but they're not declared. So obviously, for something to be usable, it has to be declared before it is used. So I'll just say, okay, if those are integer invoice total, for example, set to $99.99, right? And then invoice count is another integer, which is set to let's say 5 items on the itemized invoice. So if I try to run this, right, I can save it. If I try to run it quickly just to see if it can do this thing for me, the answer is no, it cannot. As you know, then I say, all right, let me find out what's going on. Usually, you can right-click here. You can just say clean and build just to see the output in details. Possible loss of precision. It happens on this line, basically the first executable line. So the compiler here really doesn't want to initialize an integer with a floating point number, such as 99.99. So perhaps my mistake was to name it an integer, to give it a type integer, so maybe it should be double. Maybe that's what I was, that was my intent. All right, so I save that and try it again, just build again. Another possible loss of precision error, and let me increase the size of this output here so you can see clear what's going on. So in this particular case, recall that now invoice total is a double. This is an integer. When a double and an integer are involved in some sort of computation, the entire expression is promoted to double, so the result the result of this expression is a double type, because one of the operands is a double type. Everything else is getting promoted to that type. And then again, we have the same situation that now we're trying to create an integer and initialize it with the double. So perhaps this was another mistake. So maybe this also needs to be a double. So doubles must be initialized with doubles, or you could cast values, but that's not a straightforward solution to any problem. It's usually indication of some kind of poor design. So basically, the types of variables that you use must reflect the types of data that we're trying to store in these variables. And finally, I guess this one was on the slide. I was trying to demonstrate what really is going to happen if we use an integer. Well, I guess if I try this, if I try to cast, still, I don't like doing it, but just to demonstrate, if I try to cast, basically say, well, you know what, I know it's a double, but I want you to kind of just forget the fractional part of it, and I want to cast it to an integer. This is the casting operator, and this is how I can still obtain this kind of silly integer result of this division, even though one of the double numbers involved. Well, let's verify this. Let's just say system.out.print result 9 is result 9. Have to have a semicolon in the end. And similarly, this guy right here. So let me just minimize this. Right. So similarly, result 10. And just run it to see what the outcome is. Right. So there you go. We have one is an integer, another one is a floating point number. By the way, if I'm working with currency, perhaps invoice total is some sort of a currency, then maybe this is not a satisfying type of output. So perhaps I need to start rounding my numbers, and maybe I also need to specify at what precision I want to run my calculations. This is going to be the topic for a future discussion. So just a quick refresher on some of the types, the data types that are possible to be used, and even the new element of casting this variable from being a double to just becoming an integer. One dangerous thing about casting double to an integer is that the fractional part is lost. Even it was like 19.8. 0.8 is pretty close to 20, but 19.8 will be cast to 19, and 0.8 is lost, is just cast away as a result of this.